Okay, so here's our non-lifting cylinder. So what is a non-lifting cylinder going to look like? I'm going to go ahead and show it to you down here. It's not perfect. I need to kind of, let's see here. Let's make the doublet 50. I think I forgot to change that back. I went the wrong direction entirely. Let's make it 125, 150. Stronger doublet. Okay, there it is. So you can see that you have this kind of shape that's moving these streamlines away, right? It's not always easy to make. I need to go through this a little bit more and choose what contour plots you can see, because there's a whole lot of lines right there towards the center, which I don't really care about. I'll fix it eventually. So what I have in this case is I have a doublet and I have a uniform flow. The doublet acts like my cylinder, okay? The doublet acts like my cylinder. And so if I want to, I can then add these two together, and I can then solve it to get this function for a uniform, for a cylinder. Now, I don't use this when I'm actually making the cylinder. I just use this guy right here. I add a uniform flow to a doublet, and I get a cylinder. Now, look at the streamlines before and after the cylinder. Do they look farther apart after the cylinder or about the same? They kind of look like they're about the same width after the cylinder, right? Okay, look above and below the cylinder. Are the streamlines there spaced out about the same? So what you're telling me is that this is perfectly symmetric left to right and up down, right? If that's the case, this is saying that there's no drag and that there's no lift. Now, it's not physical, because in real life, if I put a cylinder that's not spinning into a flow, it will have drag, but it will have no lift. So the lift is fine, the drag part not so fine. Where does the drag come from? My air doesn't stay perfectly stuck to the surface. It will separate. And this one right here, it's magically not separating. Okay, so now what we do is we go to a rotating cylinder. A rotating cylinder is simply saying I am going to cause my cylinder to spin. And so I have my cylinder right here. This is the equation for a stationary cylinder. And I add on to that a vortex flow. I simply say it's also spinning. I do that using my vortex. So I'm adding together elementary flows to make something more complex. And so to make this, I just added a uniform flow to a doublet, and then finally to a vortex flow. And what you'll see is there's something different here. Now look above and below, please. Are the streamlines spaced differently above and below? Right here. They are. So above it, very close together. Below it, very far apart. Okay? The closer they are together, the faster my flow is. The further apart they are, the slower my flow is. If I have faster air going above my cylinder and slower air going below it, I will have lift. Okay? I will have lift. Now look left and right. Now this guy's not perfectly centered because I made it, sorry. But left and right, you probably notice that those streamlines are identical. Like they're going together at the same rate and then parting at the same rate, which is still showing me that I have no drag.
So what would it be if it was reversed, where it's like it's
spinning the opposite direction?
On top, but below, but they're close together on bottom.
I'll show it to you. So right here is my vortex. I have a strength of 7. I just picked that because it worked right. I'm going to make it -7 now. That's spinning the ball in the opposite direction, spinning the cylinder in the opposite direction. I'm going to run this section so we can see what happens if I have them in the opposite place. And there you go. So that is simply that it's spinning the opposite way compared to what it's running in. So what's happening is that if I'm spinning my cylinder, okay, if I'm spinning my cylinder, it is either going in the same direction as the flow, or it is going in the opposite direction of the flow, okay? It's doing one or the other. And depending on what it's doing, it's either going to cause the flow to be faster there or to be slower there. And so if I spin it in one direction, it will go up because it's going to lift itself in the air. If I spin it in the opposite direction, it will begin to drop more quickly. So that's all that will happen. It's just going to drop instead of lifting. And let's put this right here as a positive number again. So it's all the same for next time.